Hi guys, good afternoon. So in the last session, we saw IKEv1 site-to-site policy-based between ASS. Okay. So far, whatever we have seen on the main mode only. Correct. Now, today what we'll see is we will see about the aggressive mode also. Okay. So if we look here, difference between main mode and aggressive mode. Okay. So there are two different modes for building phase one. One is main mode, and another one is aggressive mode. In the main mode, we have 6 message exchange. In the aggressive mode, we have 3 message exchange. In the main mode, there is full identity protection. Full identity protection means what? That means the identities are encrypted. Message number 5 and 6, they are encrypted. But here, even the identities are passed in what? Clear text. Okay. Then here, there is a better DOS protection, denial of service protection. Okay. So anti-DOS protection is there. And here, there is, we don't have that much better protection in the aggressive mode. Then responder must authenticate himself first, and the pre-shared key can be retrieved by an offline brute force attack also. Okay, because only 3 messages exchange are there, correct? And then here, faster session establishment is there, because here total 6 messages are getting exchanged, and here 3 messages are getting exchanged. But this point should come at the last only. You should not directly say that, okay, aggressive mode is faster than main mode. The major thing will be that here we have 6 message exchange, here we have 3 message exchange, here we have full identity protection, and here the identities are passed in clear text. Then rest of the things, they will come eventually. Okay. So now if we see here, this is the main mode message number 1. Okay. This is one screenshot of your aggressive mode. Okay. So you can see source IP, destination IP, source port, destination port, they will be same. Initiator SPA, responder SPA is also the same, because in the first message, initiator SPA will be there, responder SPA will be 0. Okay. Then after, security association payload will be there, SA payload, in which your Haggle process will be there. Other than that, do you see what is there? Yes. Key exchange. Now, key is exchanged in which message? No. Message number 3. Okay. Then nonce payload is also there. Identification payload, this is the message number 5. So that means aggressive mode message number 1 is equivalent to main mode message number 1, 3, and 5. Whatever you exchange in 1, 3, and 5, everything is getting exchanged in the first message itself. In the aggressive mode. Okay. Why the message number 2, 4, and 6, they are here message number 2, because responder will also send his Haggle process and everything. Correct. So now look here. And the third message, that is just an authentication message, confirmation message. So see here now, IKEv1 phase 1 aggressive mode. Okay. And IKEv1 phase 1, when in aggressive mode, uses only 3 messages to establish the IKE security association. The first 2 messages in the aggressive mode exchange include almost everything required to form an security association. Okay. So IKEv1 phase 1 aggressive mode is quicker than main mode, but endpoint identities are exchanged in the clear text only. Okay. So here, even the identities are exchanged in what? Clear text. So when comparing main mode with aggressive mode, main mode is considered more secure than aggressive mode. Why? Because the identification payload is encrypted in the main mode. There it is encrypted. In the aggressive mode, it is in the clear text. This is clear. Okay. Now let's talk about message number 1. So in IKEv1 phase 1 aggressive mode, all the necessary information that is required to generate the Diffie-Hellman shared secret is exchanged in the first 2 messages between the peers. Okay. So the first message sent from the initiator, it will include what? It will include your essay payload, proposal payload, and the transform payload, which is similar to main mode. The main difference aggressive mode is that first message will also include what? Your Diffie-Hellman key exchange payload, the nouns payload, as well as the identification payload. Everything. Message number 1, 3, and 5, all things are exchanged here only. And you have to note that the identification payload is sent as a clear text, not encrypted. Okay. Then message number 2. So message number 2 will be what? Now the responder can also generate the Diffie-Hellman shared secret. The responder will generate what? The Diffie-Hellman shared secret, and it will generate the hash also for authentication purpose. Okay. The hashes, remember? Similar to message 2 in the IKE version 1, phase 1 main mode. Okay. And the message 2 in the IKE version 1, phase 1 aggressive mode also contains the agreed proposal. That means if the initiator is sending multiple essay, then which essay will be selected? So the agreed proposal and transform pair from the responder, and it is also going to contain the key exchange, nouns, and identification payload. And here there will be a authentication hash. These all things will be there. Clear? Okay. So message number 2 is equivalent to 2, 4, and 6. Okay. And message number 1 is equivalent to 1, 3, and 5. Okay. Then the message number 3, authentication only. So now the initiator can generate the Diffie-Hellman shared secret. The initiator generates Diffie-Hellman shared secret, and initiator generates a hash for authentication purpose, and the hash payload is sent as encrypted. So first of all, responder has authenticated. Now what? Initiator is also authenticating. And this way, your 3 message exchange will be there. Now, after these 3 message exchange, there will be again what? Your quick mode, phase 2. Okay. So these are main mode, Diffie-Hellman.
Aggressive mode is totally insecure. Why we are using?
We are not using. It is just there, but we are not using it. In the real scenarios, always and always your main mode will be used with the IKE version 1. And right now, we are mostly going with the IKE version 2. Okay. This is clear? Okay. So let's go for the configurational part. Aggressive mode configuration. There is only changes in the key generation process. That's it. Done. Site 1, site 2 is key. Okay, let's use the same lab. I'll just clear the configurations. Yesterday, who didn't get a chance to configure? Come forward. You have done it, right? Yesterday. Observe. It's okay. Even if you remember, also you forget when you come here. Because aggressive mode configuration, I will tell you. Hmm? This one. Hmm. Yeah. Okay. So I think one. Yes. So I believe, yeah, SP also fine. Site 2 also paste it. Then SP. So first of all, we will test public to public connectivity. That is from 11.1.1 to 12.1.1. Ping 12.1.1. So we have the communication. Okay. All right. Now what we'll do, we'll do the configuration. Okay. So let's go for VPN configuration. Just see, first of all, what we are doing is we are creating the ISACAM policy. So we will say crypto ISACAM policy and number. Then idle process hashing. Let's go with SHA-256. authentication, pre-share, group, 14, encryption, AES, then lifetime is 86,400. This will be safe. Okay. So let's copy and paste it. This is done. Now, save crypto, IKEv1. Now, you see, this is to disable the aggressive mode. Okay. Then we will say crypto IKEv1 peer address. And what is my peer? 12.1.1.2. Enter. Now here I have the set command. I'll say set. Then I have aggressive mode. Now two options are there. One is client endpoint and second one is password. So first of all, let's go to the client endpoint. Now here, either you give FQDN, user FQDN, or give IPv4 address or IPv6 address. So right now we'll give what? IPv4 address. IPv4 address. Now what is the IP address? Okay, so use this IP address as the tunnel client endpoint. So that means self IP address we are talking about here. So which is 11.1.1.1. Okay. Then after nothing. Then we will say again use set command. Okay. And we'll say set aggressive mode password. Okay. 0. And what is the password I want to use? Cisco. This is done. So what are the commands we used? Peer address. Okay. Then after using peer address, we used client endpoint address 11.1.1.1. Then we used password. Okay. This is done. Then next is what? Same way we will configure what? Transform set. Okay. So I'll say it. Okay, this is done. And then here, no other option. Then we'll say crypto, IPsec, transform set, ESET, ESP AES, ESP, SHA. Okay. This is one command we have used. After this, access list 100 permit IP from host 10.1.1.1 to the host. And this is done. And this is our access list. After that, so map, CMap 10. Then after, you will say IPsec, ISECM. Then after, set peer 12.1.1.2. Transform set, reset, match address, and ACL number is 100. Okay. So interface G0/1 crypto map C. Okay, because here we are using the interface G0/1. So interface is G0/1 crypto map C. Let's see. IKEv is on. Now this is the configuration we have done on site. Copy. On the site B, what will be the change? Peer IP address. So here peer IP address will be 11.1.1.1. This IP address will be 12.1.1.2. Yeah. So access list will change. Here also peer IP address. And here the interfaces is 0/6. Copy. Site to paste. Now let's go and capture. This site capture is going on. Let's try to pin. Loopback misses. Ping 10.2.2. This is not an IP address, this is MAC address. For the loopback interface. So loopback means it will see source is also same, destination is also same. It will remain within your NIC only. That means kind of NIC test it is. Hmm. Let's try to ping. Do you see here the message capture? This time instead of main mode, what do we have? Aggressive mode. Hmm? I don't know. I'm also capturing in front of you only. Not doing any magic. We'll see what is the issue. So you can see aggressive mode is there, then quick mode is there. And aggressive mode, how many message exchange is there? 3 message exchange. Let's go to the first message exchange and then let's open the second message also. And this is the first message. So source IP going from 11 to 12. This is from 12 to 11. Okay. So we are saying that this is aggressive mode, right? Message number 1. This is aggressive mode, message number 2. On this side, this is what? Initiator. And this is responder. Now, expand ISACAM. Here also expand ISACAM. Initiator SPI, responder SPI. Right. So this thing we can check here that here we do have what? Initiator SPI, but there is no responder SPI. And when the responder will respond, it will have initiator as well as responder both. Now, what is the next payload here? Security association. Here also security association, and exchange type is what? Aggressive. Okay. And I question is these things we can verify. Okay. Let's open the security association payload. In the security association payload, we do have what? Proposal payload. Expand the proposal payload. Inside the proposal payload, we have what? Transform payload. Transform payload. Okay. So here we can see the haggle messages, the haggle parameters. Same thing we can see here also. Okay. This is clear. And here you can see that vendor ID payload for negotiation of, that means checking the support for, checking support for NAT-T. This payload is there, right? The RFC 3947, negotiation of NAT-T. Okay. And this side also, if you check on the other side, we do have this payload here also. There it is. And here, this here. This is clear. Yes or no? Okay. So until now, this was first message and second message according to main mode. Now in main mode, the third message and fourth message. So third message and fourth message are about key exchange. See here. We have the key exchange, we have the nonce payload. This is the key exchange. This is the nonce payload. Right? Nonce data, key exchange. Here also we do have key exchange and we have nonce. This is the third and fourth message. And you can see we do have what? NAT-D payload also. Clear? Okay. Then after message number 5 and 6 was about identity. So here we can see identification payloads are also there. But here the identification data C ID is IPv4 address. And here 12.1.1.2. So in the identity payload, what happens that they are sharing their own IP address. They are sharing what? Their own IP address. So this is the identity payload. And for authentication reason, what happens? See, for authentication reason, it is sharing this hash payload also. Here it is sharing this hash payload. This hash payload is used for what? Authentication. That yes, the initiator or the responder, they are the correct entity. Okay. So see, in the first message, we don't have this hash payload. Who is sending the hash first? Responder. So the responder is getting authenticated first here. Okay. This is clear. Now after this, rest of everything is available here. So only initiator needs to authenticate. So if you check the third message in the aggressive mode, okay. So this is encrypted now. Okay, you won't be able to see. Yeah, data will, right? This is the third message, authentication data. So this will be encrypted. But first your initiator will be authenticated, then after your responder will be authenticated. Then we have main mode. So main mode is completely encrypted. This is clear. Okay. Now, one thing we can try here. What I'll do is I will clear the tunnels. Close it again. And let me start the capture again. Okay. So what I'll do here, I'll say clear crypto session. Everything got clear. And on the site too, I will start a debug. Debug crypto ISACAM. And also I'll say debug crypto. So first of all, let's go with the ISACAM only. Then after next time, we will see about IPsec. Let me try to ping again. Let's see what are the logs generated here. So many different logs will be there. Okay, I have to just one time let me clear. Clear crypto session. So it will say everything is cleared here. Establish it. Okay. Hmm. Here. Received packet from 11111. Destination port is 500. Source port is 500. Created a peer structure for this. Peer port number is 500. Okay. Then they have created the identity for the peer. And then again, they are saying that, okay, this is the source, this is the destination. Okay. And address is what? 11111 and protocol number 17, which is UDP. Okay. Then they are saying that, okay, vendor's ID seems Unity PSD is this, but major 69 is mismatch. And another vendor ID payload, RFC 3947, which shows the support for NAT. Okay. Then after see here that SA is using the tunnel password as pre-shared key. Local pre-shared key has been found. Scanning the profiles for the authentication. And these are the parameters. Right? These are the parameters they are checking. Okay. Then after, all the attributes are acceptable. The lifetime. Okay. Then after, if you see processing the nonce payload, you can see the key exchange payload. Okay. Then we have so many different vendor ID payloads are there. Multiple are there, not only one. Okay. Pre-shared key authentication using the ID type, ID IPv4 address, and it has sent its own ID address, ID there. Correct. Then sending the packet to 11111. My port is, that means source port, peer port. Okay. So sending an I message. Then it has received a reply. Processing the hash payload. This was the third message. Okay, in the third message, they sent the hash. Okay. And you see, so they check the, so like NAT B test is being done here, that his hash no match this node outside NAT. Okay. And also it says no NAT found for cell for the year. Okay. Then you can see it says what? SA has been authenticated. Then trying to insert a peer and inserted successfully. After that, received a packet again. So then later on, it was phase 2. See, in the phase 2, ESP, AES. Okay. Then HMAC SHA was there, key length is 128, all the attributes are acceptable. So this kind of entire process is going on in the backend. Okay. But these debugs, you don't have to use them in the production environment. Sometimes for, if there is a error you want to troubleshoot, in that case you can, otherwise this will be too much resource and extensive. You can see just for 3 messages, like how many logs are generated here. Okay. And you can see in the phase 2 also there are nonce payload. Okay. They have their nonce payloads. Okay. Then anything else we can, okay, that is it. So this is clear how you will check. Now, if you want, we can go and check the IPsec also. This is Isaac and debug only. Okay. So now if I say IPsec, is run debug. From here, crypto session. These are all IPsec debugs. Now let's initiate again. See here, IPsec got a queue event with 1 message. Okay, and inbound local is this, peer IP address is this, and then they have sent this, is the ACL is this one. Okay, so you see here it says there is a proxy match from source address 10.2.2 to 10.1.1.1, and these are the transform payloads. So they are using what? ESP, ES, ESP, SHA, HMAC. Okay, the crypto map number is CMAP10. Then after C here, they are checking the SPAs. Okay, and then after, okay, this is it. We don't have too much of things. This is again, they are telling about the source and destination only, that which traffic they will be securing. And then they have the SPAs. Okay. Nonce payload means this is used to prevent replay attacks. That means if I'm sending you a key, with the key, I will send a nonce payload also. In the nonce payload, I will use a random number. So when you are responding, so you have to use the same number. No, key is different. Along with the key, one nonce payload. Like, TCP header is there. In the TCP header, one extra thing you say, that's some. So alongside the key, you will also exchange nonce separately. If you see here in the capture, let me undebug this. That there is a key payload. Okay. See here. Key exchange is there separately and nonce is there separately. So here, this guy was using the nonce as what? 10. So now when he will get the response, in the response also, the nonce value will be 10 only. Okay. Okay. This is the non-spy mode. Clear? So aggressive mode is clear. Yeah. Now let's go with the route-based VPN. Diffie element same process. Okay. They will again use the Diffie element process only. Now let's talk about route-based VPN. This is aggressive mode configuration. Save as IKv1 policy based 5 to 5 VPN. With for sorry again. Firewall, yes. Even that, even if you are using a virtual machine firewall also, that will perform the translation. Which one? These configurations. Then you can configure them in the virtual firewall only. When we studied FTD, we studied site-to-site VPN in the FTD. So we were performing it in the here only. Okay. So policy-based site-to-site. Okay. This is for the aggressive mode. Now, let me close this lab. And I will clone this lab. And this is without MAC key. And we will name it route-based VPN. So this time we will use what? GRE. Wipe all the nodes. GRE, route-based site-to-site VPN. Okay. And here, without MAC. Okay. Now, what is the difference between a site-to-site? I mean, between a policy-based and route-based VPN? Hmm? Router decide. What is the name of the table? Routing table. Okay. So in the GRE, what will happen that your routing table will make a decision. See, right now, if I say we have to first of all do the basic configuration. So who wants to do it again? No, you haven't done the configuration, right? Yes, please come. Everybody should get a chance. Yes, basic configuration. The more you do practice, the more you will learn. No, it will be different. Today we'll go with GRE and tomorrow we'll go with GRE over IPsec. So today what we'll do is this tunnel we will create, it will not be secure. We will create a GRE tunnel. We will have loopback to loopback communication also, but the tunnel will not be secure. Okay.
Yeah. It is encapsulation only.
Encapsulation only. Yeah, because see that tunnel does not have any encryption. There is no CIA. Okay, when you use a route-based VPN by default, when you use GRE, in that case, there is no encryption defined, no hashing defined. So no integrity, no confidentiality, nothing. Mhm. What happened? Uh-huh. No problem. Continue. Default route is checking. Next line. Limit. Hmm. So what do you think? Like, what is the difference, actual difference between your route-based and policy-based? One is ACL will decide, routing table will decide. Any other difference? Hmm? Like what? Hmm? Other than that, what is the difference? This is also site to site only. Route based and policy based. Configurational difference is there. That is not considered. IGP protocols, okay. And hmm, this is your task to find out differences. At least 4 to 5 differences you have to find out between route based and policy based. Okay. 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 Rest of the everything is good. Now understand here that I have this basic configuration. Now with the help of this basic configuration, I will get what? My public to public connectivity. Okay. And if I want that, okay, my 10111 should have communication with 10222. So will I be able to have or not? Mhm. Mhm. So on site one, you can add the route. Mhm. Can we control ISP? No. So definitely this communication will not be there. Correct? This communication will not be there. Okay. So even if I will give a static route this side and static route this side also, there will be no communication. Right? Communication is not going to be there. So what we'll do here, what we are going to do is we are going to create a tunnel interface. Okay. We are going to create what? Tunnel interface. Okay, and with the help of tunnel interfaces, one tunnel will be created, which will be known as your GRE tunnel. This GRE tunnel will be created, and then your traffic will pass through the tunnel. Now, if you are creating a tunnel interface, okay, so on this tunnel interface also you have to assign an IP. So what we are going to do, we are going to assign a private IP. Okay, for an example, on site 1 to this tunnel, I'll assign, let's say 1.1. Okay, and this site, let's say I will assign 1.2. Okay, and when I will define a route, I will define a route that, okay, if you want to reach 10.2.2.2, your next stop will be what? And this side 1.1. Okay, so this way we have to define the traffic. Okay, so let's go and copy it.
Basic reason, when we are applying this tunnel interface,
Mhm.
it will not be directly for
No,
them.
tunnel interface, this is a virtual interface. Again, your actual communication will happen through the ISP only. Okay, so what GRE is going to do, it is going to encapsulate your traffic. Like normally when you will ping from 10.1.1.1 to 10.2.2.2, right? So your source IP will be 10.1.1.1 and destination IP will be what? 10.2.2.2. But what GRE will do, it will put an GRE header. Okay, like how it's going to look like.
It has to increase because
So whatever is your data, okay, let's say this is your ICMP payload. This is your payload where you're sending what? ICMP. So over this, you will have a source IP and then you will have a destination IP. So source IP here it will be right. Now above this, what will happen? There will be one extra header, which is GRE header. Okay. And over this GRE header, we will have one more header. This is the new IP header. It will have a source IP. It will have a destination. Here source IP will be 11.1.1 and here it will be 12.1.1. So when your ISP will forward the packet, ISP will forward it according to this. ISP will not check the internal IP address. Okay. That is just a virtual interface, and that will just be used to forward these packets through the ISP. You will not see 192.168.1.2 anywhere. In the routers, you will see. In the routers, you're going to see, but ISP you cannot see. In the Wireshark capture, you will not see. Okay. Okay. Copy, paste, copy, paste, copy, paste. Okay, post name column. So first of all, public to public communication bus test. Blueprint. I have the communication. Okay. Now let me try blueprint 10.1, 10.2.2.2 source 10.1. Yes. Mm. No communication. Okay. Now what we'll do, we'll go and create these tunnel interfaces. Same like loopback interface, you create them. So right now, if I say do show IP interface brief, do you see any tunnel interface here? No, right? We don't see any tunnel interface here. Same way here also. We don't see here. Now what? Let's go and create one interface. So I'll say interface tunnel, and you can see again same like loopback, multiple tunnel interfaces you can create. So let's say one. Okay. Now we will assign IP address. IP address. Let's say 192.168.1.255.255.255.0, and it says tunnel interface is down. So let me say no show. Okay. And this side also interface tunnel 1 IP address 1.2. Let me see. Let's verify. Do show IP interface brief. Do you see? Tunnel 1 interface is created, IP is there, status is up, but protocol is what? Now. Same thing here. Right? And even if I go and see, if I show you, do show IP route. Okay, do I have any route for 10.2.2.2? No, right? I have just one default route, right, towards the ISP, but my ISP does not have a route for private network. So what I can do here, and also, do you see any route here for the 192.168 network? Even though I have configured it, even though I have configured the tunnel interface, I don't have a route in my routing table. There should be a connected route. Directly connected route should be there. Same thing, check here. This is the IP address. No route. Now why? Whenever you configure an IP address on any interface, you should have a route. My interface status is up, but the problem is line protocol is down. Okay. Why the line protocol is down? Because whenever you configure a tunnel interface, you have to tell that, okay, what from where the tunnel will start, where the tunnel will end. So you have to give the source and destination. Okay. So I'll say interface tunnel 1 source. Now either you can give the interface name or you can give the IP address. Both are your choices. Okay. So let's say 1.1.1.1. And not like this, you will say here tunnel source. Tunnel source 11 okay, and then you have to give the destination. Destination will be 12 Now you see line protocol on the interface tunnel 1 change state to up. Same thing we have to do it here. Okay. Interface tunnel 1 tunnel source and tunnel destination 11 Once you do this, now you should be able to see the route also. You see, I got a connected route here, and also I got a connected route here. Okay, and let me test the communication between my tunnel interfaces. So I'll say ping 1.2. My tunnel interface communication is there, and if my tunnel interface communication is there, now what? If I want, I can configure a static route. If I want, I can use a dynamic protocol also here. OSPF we can use or EIGRP. In most cases with GRE, we will see EIGRP only. Why? Because GRE was initially Cisco proprietary and EIGRP was also Cisco proprietary. So better compatibility, EIGRP. Okay. Hmm? Hmm? No, it will not act like anybody. This is just a virtual concept. And whenever you will generate a traffic, also you will not see, let's say, whenever I'll try to ping from here.
When we generate the packet, then the source IP will be 11 dot 1.
Yeah, outer IP header, inner IP header.
We are one.
You will see 192.168 only if you are generating this specific traffic. Which one? GRE header will be there. Over the GRE header, new IP header will be there. See this. This is in between GRE. Okay. So let me capture the packets and show you. Let me capture and show you. Don't worry. Okay, so if I go and ping, first of all, let's test the tunnel interface only. You see, I see what is going on inside. So I have my inner IP header. Right now, I just ping in the tunnel interface. That's why you are able to see these IP addresses. Okay. And over it, I have another IP header, which is to 12.1. And this is your GR. That's it. No IP address information or anything. Okay. Then inside it, we have the ICMP. So we are able to see the ICMP also. Okay. Now, like I said, what we can do is we can go and use a dynamic routing protocol here. So let's say I will go and configure EIGRP here. I don't want to configure static routes. Okay. So what I can do here, I can go and say router EIGRP10. Then I can say, first of all, no auto summary because in EIGRP auto summary is there, right? And what is auto summary? Because by default, summarized to classful boundaries. Okay. That in EIGRP, what happens by default, all the subnets, they will be summarized to classful boundaries. That means default subnet mask will be shared. So we don't want to share that. So now here I'll say network 10.1.1.0 network m.z. Okay. And now See, right now I don't have a route in my routing table, right, for 10.2.2.2. If you check here. So if I will try to ping, my traffic will not pass through the tunnel. Okay. So either I can use a static route. In the static route, I can use the next stop as 1.2. And then my traffic will pass through the tunnel. Or else what I can do, I can use a dynamic routing protocol. Yes, default route also you can do. But then there will be two default routes. One for the ISP, another one for the, right? And what will happen if there will be two default route, your router will start doing load balancing. So one packet through internet, another packet through tunnel. Okay. And what if, let's say, for example, I give a static route from site 1 for 10.2.2 on this site. And on site 2, if I don't give a route, my reply traffic will not come. My reply traffic will not come, right? So those kind of issues will be there. Then it will come. Okay, so I'll say router GRP 10. So if our AGRP neighborship will be established, we won't face any problem. See, neighborship came up. Now we should have the routes. We'll show IP route. So I got a route for 10.2.2.2 and this site will show IP route. So this side I can see a route for 10.1.1. And you can see through which interface? Tunnel interface. Now what? If I go and try to ping from here and packet capture is going on. Okay. Do you see we can already see the EAGRP hello messages? Okay, and even these EAGRP hello messages, they are having the GRE header. Okay, because anything that is going through the tunnel. Okay, now let me see. 10 dot. Now even I don't need to mention the source also. Simply if I ping, so it will use the source as my tunnel interface. And if I say that, okay, use the source as 10.1.1.1. So this is what I was talking about, that you will not see anything. If my internal subnet is pinging with the internal subnet, then what is happening? That anywhere you will not see the tunnel interface name or anything.
We are able to see the tunnel IP.
Where? Where is it? This is because I pinged from the router. Now in real scenarios, you will not ping from the router. Your internal clients, they will go to their internal clients. This is this case. And in this case, you can see here that we are not seeing the tunnel IP anywhere. So you have your internal data, your IP header, then your GRE header, again a new IP header. This is clear. So right now it is, you can see, completely insecure. We are able to see everything. Okay, anybody capturing the packets, they can see like, okay, this is ICMP for reply. Okay, then going from this IP to this IP.
Also private IP.
Yeah, your private IPs are visible right now. Okay, so these things tomorrow we will apply IPsec to secure it. Right now there is no confidentiality and integrity. Is that clear? So in the route-based VPN, only one thing you have to take care, that here routing table will make a decision that, okay, which traffic will pass through the tunnel. So in my routing table, I have a route that, okay, the traffic should pass through the interface tunnel 1. Okay, so your routing table is making a decision. Second thing, that here one more issue is there, that here we cannot decide that, okay, which traffic will, first of all, like once tunnel is created, if I'm using a dynamic routing, so once tunnel is created, after that what will happen, that I cannot decide that which traffic should be encrypted, which traffic should be hash, should have only confidentiality or only integrity. Those kind of things I cannot decide. Policies I cannot apply. Okay, but here, I mean, in the route based, I cannot apply policies, but in the policy based, I can apply policies. We can decide that, okay, which hashing algorithm will be used and everything. This is clear. Okay, and when today you will do the research between policy based and route based, you'll automatically come to know the differences. Is that clear? So tomorrow what we're going to do is GRE over IPsec. Okay, so one more difference thing you have to check, the difference between GRE over IPsec and IPsec over GRE. Because sometimes in the interviews these terms are used and students get confused. IPsec over GRE. This is what you have to check. Is that clear?
Yes.
Okay. Online people, any doubt? Yes or no? Okay, two things for research. That is difference between route based and policy based. And second thing, GRE over IPsec or IPsec over GRE. Okay. All right. So I'll see you tomorrow then. Have a good day. Bye bye.